In this video, we're going to be multiplying rational expressions. So here, it looks kind of complicated, but really it's just one fraction times another fraction. So instead of taking our 2x squared plus x minus 6 and multiplying it with the x to the third minus 3x squared plus 2x, the first thing we actually want to do is factor each of the rational expressions and then go from there. So we're going to go ahead and we're going to factor all four of these expressions. So as we factor 2x squared plus x minus 6, we see that our leading coefficient is not a 1. So we're going to go ahead and use our box to factor that. So we put our 2x squared in the first box and our minus 6 in the last box like we're supposed to. Then we multiplied our 2x squared and our negative 6 and got a negative 12x squared. So we're going to split the x squared and put an x in each of our leftover boxes. And then we want to break apart our negative 12, and go, what two numbers will multiply to negative 12, but will add to 1? And that answer is 4 and 3. And because we need to be a positive one, we'll keep the 4 positive and make the 3 negative. So we'll put our 4x here and our negative 3x there. And now we just need to know, what do these have in common? And that answer is a 2x. And then what does this row have in common? The answer is a 3. Now because our first thing is a negative, we're going to put the negative out in front. Then we're going to look and see, what does our first column have in common? And the answer is they only have an x in common. So we're going to go ahead and we're going to write down an x. And then we're going to look at our second column, and we see that they have a 2 in common. So we're going to write down a 2. And now we can write down our factors, which are x plus 2 and 2x minus 3. So these become the factors of our first fractions numerator. So we can put that in its place. We can go ahead and we can put our two fractions right here. We'll write down our x plus 2 and our 2x minus 3 from our factoring. And now we're ready to factor our first denominator. So here we have x squared plus 4x minus 5. And because our leading coefficient is a 1, we can try and decide what two numbers will multiply to negative 5, but will add to 4. That answer is a 5 and a 1. And because we want the 4x to be positive, our 1 will be the negative. And so we can write our factors as x plus 5 and x minus 1, and those are reduced. It can't go any lower, so they're completely factored. So now we can write that in our space provided for that first denominator. And now we're ready to factor our second numerator. So here we actually look at it, we can see that there is a common number with all of these things, a common factor. So we can actually take out an x from each of these. So we're going to pull out an x, factor that out, and that's going to leave us with an x squared minus 3x plus 2. And now we can factor that. So two numbers that will multiply to 2 but add to a negative 3 would be a negative 2 and a negative 1. And so we can write that down as x times, because remember our x has to come down, x minus 2 and x minus 1. And we can see that that is completely factored. And so we can now write that up in our fraction bar. And now we're ready to factor our first denominator. So as we look at 4x squared minus 6x, we actually see that they have a couple things in common. We can take out a 2 and an x from both of these. So if we take out a 2 and an x, we are then left with x minus 3. And we see that that can't go any lower. So that is now completely factored. And we're going to put that over here in our denominator spot. So 2x times x minus 3. And now we want to reduce this to make this as easy as possible for us. But remember, we can't pull things apart. So our x plus 2 right here, that's its own family. And our 2x minus 3 is its own family. And our x plus 5 is its own whole family. You can't break these things apart. Here we have an x minus 1, and all of that goes together. Here we have a 2, and that's its own piece. And here we have an x, and that's its own piece. And here we have an x minus 3, and that whole thing is its own piece. And we've got an x up here, and that's its own piece. And we have an x minus 2, and that's its own piece. And we have an x minus 1, and that's its own piece. So we want to look and go, what can we take out? What things match? And so here I can see that there's a plain x here and a plain x there, so we can cross those out. And looking, we also see that there's an x minus 1 in the denominator and an x minus 1 in the numerator. And that's it. Nothing else matches. So we can write what's left over. Oops, we see that it made a small math error here, so we're going to come back and fix it. So we're going to come back over to here. Hopefully you guys caught it. That 4 divided by 2 is not 1. Then we need to change that to a 2x minus 3, which is going to change this piece to a 2x minus 3. Well, that made a big difference. Okay, so now we can also see that we have a 2x minus 3 that matches in the denominator and the numerator as well. So now we're ready to write what's left. So we have an x plus 2 left on the top and an x minus 2 left on the top. And in the denominator, we have a x plus 5 left, and we have a 2 left. Don't forget about that too. We didn't cross that out. So now we're going to rewrite this as x plus 2 times x minus 2 over 2 times x plus 5. But we also need to know what are all the things that x is not allowed to be. So we need to go back to our denominators and see what we crossed off. We crossed off an x minus 1, so we'll set that equal to 0. We also crossed off a plain x, so we're going to have to set that equal to 0. And we also crossed off a 2x minus 3, so we need to set that equal to 0 as well. Because remember, these are going to be the values that would make our denominators 0, which would make them undefined. So here we see that x would equal a 1, here x would be a 0, and here when we solve that out, we see that x would equal a 3 halves. And so these numbers right here are the numbers that x is not allowed to equal. So we'll say x cannot equal 0, x cannot equal 1, and x cannot equal 3 halves. And this is going to be our solution right here. So it can seem like it's a lot of work, but really, your first step is going to be to factor the rational expression. Second is going to be to simplify. And your third step is going to be to find out what x cannot equal. So if you follow these 3 steps, that will help you stay organized and get to that right answer.